Okay, good evening, everyone. So welcome back to RoboCup at Home Education online classroom. And today we have standard platform, week number 5. So we will talk about pepper movement and multimedia development. So I'm Jeffrey from at Home Education, and together with me today we also have SoftBank Robotics engineers Austin and also Lin Chong. Okay, so let's start the class, but just one announcement is like for those who join because you want to know about the competition, so we will do the explanation about the competition as well after we have finished the pepper movement and multimedia. So please stay back and enjoy the class. Okay, so this is the arrangement as usual. We will start at 7:30 and this will span about 2 hours. Maybe today the content will be a bit longer, so I hope to make it brief so that we can cover everything on time. As usual, we have a meeting link there, so just in case any of your colleagues still on the way, so you can send the meeting link to them and let them join in as soon as possible. For the online classroom arrangement, just in case that you might want to find back the other class or the class that we have done previously, so you can find the details and also the materials from the first two. The first one is the arrangement for all the classes, and the second one is the course material. Of course, if you some actually asked me about the video, so you can head to the robotforall.net website. You just enroll the course material and you can find the previous week's video record for all the classes as well. Okay, so today will be the last week for this online classroom series. And so after this, if you need anything you want to discuss, feel free to contact us, or you want to do a discussion, we can do it in the classroom group. Okay, right. So let's get started. So before I start, a final reminder as a privacy, so please refrain from turn on your webcam and also your microphone when we are doing the deliver or when SoftBank engineer is doing the demonstration. But we are encouraging you to interact with us, so we will give you time to ask questions along the class, and also we have a Q&A session by the end. So just in case you have anything you want to ask in the class, okay, you can ask during the Q&A time, and also you might want to ask some question regarding the competition, so you can do it later in the Q&A session. Okay, right. So let's get started about pepper development. Okay, so today the content we will arrange in such a way. So the first one is about pepper movement. So last week we talked about the body movement, how to move the head, the neck, and also the two arms of pepper and also the upper body, right? So today we will talk about how to move the robot around. Okay, how to move the pepper movement with the omnidirectional wheel down there. Okay, and we basically divided into two. So the first part is this people tracking. So not only just to move, but also we try to combine with the visual input so that we can make pepper to track certain human in front. And this we call it the Follow Me program. And this application is very popular because like a lot of time you want pepper to interact with human. So one of the way for pepper to actually follow, or how to say interact, is to make pepper move close to the person, and then after that maybe that person, if let's say like is moving around, so we can use this Follow Me program to actually make pepper track the person. Okay, and this tracking is not just the lower body, but it's also involve the upper body and also the head. So later you will see like we have a few modes for this Follow Me program. Then the second part for this pepper movement is, of course, the whole body movement, which means pepper will move around in the space given. And we will talk about several ways how to move pepper so that we can make sure that movement is safe. Okay, it's not like an open loop move, but we also have some safety features, And then we will see how we can design the movement so that you can also cooperate this movement with the body movement that we learned last week to complete the whole dancing performance. Okay, so this basic movement we introduced in the Pepper movement development. Okay, so this is first part. And then the second part is the Pepper multimedia, right? So this Pepper multimedia is, we will talk about the display, right? So we know that there is a tablet in front of Pepper, okay, at the chest area. So this display, we can actually show some additional information to complete or to enhance the delivery, the material delivery of Pepper. Okay, so for example, like we can play a video, we can play some sound, and also we can have some interaction. For example, like we have, for example, if Pepper is, for example, the staff of a hotel or the staff of some retail shop. So we can use the tablet to actually display some information about, for example, the product, right? And then the user can actually interact with the tablet as well. For example, like they can choose a different type of product, and then you can display some multimedia information and so on. So that all are the function that we can try to achieve with the tablet in front, and we will explain in the Pepper multimedia session. Then after that, because today is a final class, so we will do the conclusion. So I will conclude from the first class until today. So how we can put them together, and we have a further development part where we will show you some example how we can actually combine these features to develop some additional or some how to say integrated application. Okay, that you can use Pepper for certain application, real world application. And also after all this content, we will enter the competition development, which I will explain some detail and latest update about the competition. Okay, right. So these are all the content for today. So let's proceed with the first one, people tracking, follow me, the follow me program. So to use the people tracking, we can use these two instruction box. So we can see we actually have one is called the face tracker. Another one is this people tracker. So for face tracker is people can use 3 different mode to track the human face. All right. So face tracker, follow the name, is we can use this instruction box to make Pepper trace certain face. So it actually use the face detection features to detect the face. Then after that, it will control Pepper to track the face. Okay, and then you got 3 different modes: the head, the whole body, and the move. Right, head, whole body, and move. So what is this head, whole body, and move? Is basically we indicate which part of Pepper you want to make it respond to the tracking. So for example, like if we want the Pepper to track the face with just the head, so which means the body is not going to move, but Pepper just trace the face with the head. So which means like if the face is moving around, then Pepper head will actually follow the face. And if whole body, then if whole body, but whole body not include the movement, the bottom movement. So which means Pepper will still be stationary, and the final mode is the move, which is Pepper will actually move forward, backward according to the face location, right? So similarly for the people tracker, it is to track a whole body, or how to say, the people. So which means sometimes when we want to track someone, we cannot see the face, especially for example, the person is standing back to us. I mean like facing back to the Pepper. So during that time, you need to use this Pepper tracker, which is the tracking way, or the detection mode is using the whole body detection. It's not using the face detection. So there is a difference between these two, and maybe later on we can see in the demo like how are they different? What are the difference when we use face tracker and people tracker? And you can see similarly the tracking mode, we actually have 3 tracking mode, right? So the head, the whole body, and the move. So we can actually design how Pepper can behave in the tracking according to whether we want to track the face or the people. Okay, so we have these two instruction box, and you can see the input and output for these two instruction box. For the face tracker, the input is very normal, on stop, on start. Then the output is on stop. Then we have one target loss and target reach. So one is telling you that the tracking is possible because like you already reached the target, or target loss, which means Pepper actually cannot find that person. All right, so target loss. Right. So similarly in the people tracker, we have on stop and on start, but we have one more input if we want to use the people tracker, which is the people ID. Okay, so this one we have the people ID. Then for the output, it is similar actually, on stop, target loss, and target reach. So this people ID is the ID that we need to get from the system when multiple person actually being detected. Okay, and later you will see like in the example how we actually get this ID. Okay, so for example, like if we want to track a group of people, so we want to track one of them, so we need to indicate that person ID so that we can do the people tracking. Okay, so this is the explanation on the instruction box. Okay, let's go further into our example. So you can open up the example that we have provided. So if you open in Choreograph, you can see we actually have two sets. So one is the face tracking, face tracker. Another one is the people tracker, people tracking. Okay, and this one we have a delay, but it is actually a combination box. So we need to go one level lower to see what are the content inside there. Okay, so for the face track, you can see inside there we have the original face tracker. Okay, so we have the face tracker. Then we have the text. We can see the text is to make Pepper say out certain thing. So the first one is I can't see you. Where are you? All right. So this one I believe it is actually connect to the output that when the target lost. So when the target lost, Pepper will say I can't see you. Where are you? Right. Then we have another one which is I'm following you. So I believe this one is the target reach. So when we can get the target, so Pepper will say I'm following you, and Pepper is actually moving, right? It's actually responding, it's actually tracking, and also it say I'm following you. Okay, so basically that is the idea for this face tracking. Then for the body tracking, we can see that we have the people tracker down there, which is the original one. Then the right hand side is very similar to face tracking because like one is for the target loss and another one is for the target's reach. So they will say accordingly. But if you remember, I said the difference between face tracker and also people tracker is the input. We have one more input, which is the people ID. So over here, you can see we have another two additional box, which is one is subscribe to event, right? So later we'll see what event that this box subscribe. Then after that, we have one output ID, which is basically, I think, is to extract the ID of a particular person, then send this ID to the input of the face tracker. Okay, so we need this extra thing to actually indicate the people ID if you are using the people tracker. Okay, right. So these are the instruction box that we use in people tracking. Okay, so to show you the effect, so let me play a video that we have. So this is like we use. Okay, so you see like Pepper is tracking the person, and then it's moving and try to move. Okay, although you might can't hear what Pepper is saying, like yeah, but we have the subtitle down there. So you can adjust the subtitle, you can adjust what Pepper say according to the tracking effect or the tracking condition. Okay, right. Okay, so that's all for the my explanation. So now I would like to pass it to Austin to give you more information about the actual operation in Choreograph. Okay, so Austin, pass to you.
Yeah, got you. Thank you, Jeffrey. I'm gonna share my screen.
Okay.
All right. Okay. First of all, thanks for all the newcomers or the students just joined this online classroom. And basically, we cover all this kind of programming functions with the paper for the last 4 classes. We just include the speech parts, animation, and then even LEDs and sensing for the face recognition and face detection, something like that. But in this class, we want to cover the final 2 parts. One of that's for moments, and another one's multimedia. So, as the functions introduced by Jeffrey, here I got the program with the face track and body track. Okay, I'm gonna quick introduction of this kind of all this instruction box and how the structure of the projects let you know what exactly the program is and how we run with those programs. Okay, back to the projects. We know that we just divide into different categories, like from the audio and the vision, animation, and all the contents from the last 4 classroom. If you didn't get it, just you can try to rewind the video online to see the recording video. And here we're gonna move to this movement parts. We can see that we have 2 projects here. One is the track, another basic movements. Okay, we're gonna open this track projects. We can open. So that's the project introduced by Jeffrey. So as you can know, we always just pick some important instruction box from each category. It's like from the animation, we know that we have timeline, and I even have others instruction box. Very important. This is how specific function let the pepper dance or do some entertainments, because the pepper have 25 degree freedom. So that's the basic instruction box from the animation. And still speech, we know that we want Pepper to see something. We can pick some see and an animated say and say test, something like that. And LEDs, we know that we can control the LED from the Pepper's shoulder, and even to control the eyes. And face for sensing, we know that is which is a pick some important instruction box for, it's like a face recognition and face detection. But so at this parts we want to talk about the movements. So inside of that, we know that have lots of box here. It's like they just divide into different folders. They have motor, navigation, oriented, posture, safety. Those are all the introduction is all basic, and it's all represent all the functions from the paper. So here we because we only have limited time, we needed to cover some important instruction box. This project just show for us. One is a face track, another one we call it a body track. But by the way, if you want to know more functions from there, the important parts for navigation, you can use the box from here to make Pepper move as the path designed by you, and even use a motor, some other instruction box to control Pepper. But it is all about movements. Okay, back to this project, we know that we have 2 important instruction box we want to introduce. One is for the face track. So that's basic I think this is basic instructions for use those instruction box. They must have delay a box, instruction box, and another one we call the face track, but we know that is a combination, combined box, right? And why we needed delay? So For those hardware, when we use the face tracking, we need the eye from the pepper. They need to I need to get the resource from the camera, and the cameras only have one, or even we know that pepper have two 2D camera, but those are the limited resource. So our project just take the responsible for using the camera. You need to request for the camera, and after that, so after you using that, and you must release all the resource just in case other program or other people can use those resources. That's the reason why we use delay instruction box here. Okay. For the logic, it's very easy. And from the start points, we just try to have two logic line trying to start the face tracking, and another for the delay. And after the 30 seconds, then they're gonna stop the face tracking, which means they release the resource of camera from pepper. So important part for this project, we know that we want to do the face tracking, right? So here we just know that it's a combination box. We just double click on it. That's actually programs looks like, and they don't only use one box like face tracker. Other parts like they have the test edit and the C test. Those is basic instruction box from the speech category, and they just let Pepper to see something like if we want Pepper to see if I can't see you, where are you? Just say it out, and those is a test they make Pepper say it. So back to the important instruction box. We know we first of all, like what I talked before, and for the new instruction box, the first thing we need to do just compare or search from the library by keywords. It's like face. All right, face. Okay, they already have the face tracker instruction box, but we need to drag into this panel. We first we can just give quick look for the description of this box. This is tell us the box makes the robot track face with the different modes. Okay, they have the two things we need to master it. One is the face. So this box just depends on the face. They're gonna detect on the face, first of all, and the second is that they just with the different modes. Okay, so from this part, I really don't know what's most of that, but it must have some parameter to explain it. Oh, okay, we can jump after that. I can give more instruction body. So back this standard instruction box, we can compare that. We know that it's a face tracker, and even from the name and icon and important part for the inputs and outputs, it's all the same. Okay, so which means we didn't even just modify any codes or any instructor about this face tracker. It's one box, just how the one algorithm to try to get a face and then the face detection, and just follow you by tracking a face. Okay, but delayed. Even we know that in these instruction box, we really don't know the details about it, but and also we didn't modify it. If you want to see the more details about it, you can double click on it. You can see the actual codes behind it. They use some a service like AL tracker and AL memory. So if you want to know, if you want to know the in depth about the Pepper how to program with Python, you can read this this codes and behind it. Okay, in this parts, if you really don't know the Python code and even don't want to know about it, that's okay. That's what is code graph exists for, and we need to know just only to know this box. Okay, and first of all, we can check this. We can check this box, the parameter from the box. We just click the setting. They really have different parameters, and you know, they really have the mode, right? Okay, the modes have the 3 different categories. One of the for head, the whole body, the move, and okay, this should tell you if we're gonna face tracker, which parts of which part of the paper can move. It's like a move only for the wheels on the in Ender's paper, because the paper have the wheel, right? 3 is gonna omnidirectional wheel. It can move anywhere, any direction. So if we pick up this option, which means you want to move the wheel, and the whole body just only focus on the whole body, and the wheel is just to track on you, which means they don't even move the wheel. The body just try to track your face, and then the first one head. Okay, which means it's only the head is only parts can move and by tracking your face. And they even have the effector, but I don't know more details about it. What is the effector? But it's very important. Once you want to do some business application, because you want to know more details about every box. And I'm suggesting you just go back to the website to get search about what the effector is, and when we can use this effector parameter. Okay, and after that we know that they have different parameters, like the distance we want to move the paper. Once we're gonna change the head, yeah, they have some parameters, but it's not work, by the way. All right, here we're gonna choose to want to paper move the wheel, and you can sorry, you can see that we want to according to the parameter, we just let people know how to move about the width and the distance in one time, which means once I get your face, I track your face, then that's the minimum this minimum distance I need to move. So that's the basic parameters meaning. All right. Okay. After we know that parameter about the face tracker, then we need to know the inputs and outputs. Basically, and it's a standard of inputs. We have the start, this is activities, face tracker, instruction box, and another one for this unstop, which is stop face tracker. Okay, this is connected with the start and stop. Back to the road level, we know that one is that we're gonna start at the beginning of this project, and after 30 seconds, you're gonna stop the face tracking, and this is matching to this. Matching this face tracker instruction box, and for the outputs, it's kind of little more than other instruction box, because they have one algorithm and really have lots of results want the programmer know. And the first one we call is target loss. And according to logically, we know that if the paper didn't get a face, which means the target is lost, you can't get it. So that's the way you can. The paper gonna say, oh, I can't see you, and where are you? And the second about unstop. So which means once you stop the face tracker, and you're gonna stop the program. And the last one we call the target reach. Okay, in this case, we know that the pepper just detect the face, and they have their target, and it's follow the date. And meanwhile, they're just saying that I'm following you. Okay, that's a basic instruction about the face tracker, and also it's very easy. I'm just gonna give you the consequence when I show it. Okay, I'm gonna turn. Okay, I'm gonna start it. Okay, you need one person just face in front of Pepper, because you must let Pepper's eye. It's not actually from the Pepper's eye. It's from the camera on top of Pepper, because and from scratch class we know that Pepper have two 2D camera. One is from the on the top on the forehead. On the forehead, we have one 2D camera, and in the mouth, we have another camera. But in this case, we just use this on top camera, 2D camera. Those people, if one detect people, you must have you have the person just in front of the Pepper, let Pepper just detect your face. Okay, let's see what's going on after the face detect. Okay, this is trying to look at the Pepper's head. Just move, try to. That's autonomous life. Okay. Okay. Once they just catch your face, then they just follow you by checking your face. Okay, after 30 seconds, they're gonna release this the face tracking, and that's all done. Okay, that's only one instruction box, and it's very easy, and it's a very combination box we can use easily. And another one we call the body track. Compared with the face track, we know that the body track only track your body, because your skeleton, maybe according according skeleton, we know that you have arm and even the head and legs, and we know that that's one person. Then we can try to follow. We can try to track this body and detect this body and follow it. Okay. It's the same logic behind it. You know how to modify this projects. We know that we can just delete it, all this project. We need, if you want to test the body track, you need to connect to the delay, and another one just starts the body tracker, and once done, yeah, this is finish the track of the body track. Same logic. Okay, here I'm gonna try to just enter into this combination box, but it's a little different compare with the face tracking. I need to zoom it up to see more clearly. Okay, wait for a second. Okay. Okay, here we know that it's the same. It's very same with the face tracking. They just let people see something from here. Have the test connection with the C test. And first of all, we need to know that we have the body track. For the start points, they just added another box. Yeah, to another box. One is the subscribe to events, another one for the output ID, and then just trying to connect the people tracker. Okay, if you want to know why we added those two boxes, we need to know more about the people tracker. Okay, we can try to follow the schedule or follow the instruction introduced told by me. I just follow the step I do. You can know the details about the every instruction box, even for the people track. Okay, we need to find the people track. We drag here and give it a basic in and comparison. We can they have the same name and same icon in and the same parameter. It's not the same parameter, but it have this kind of parameter button. And also for the inputs, they are the same and outputs the same. Okay, I guess they didn't crack this instruction box, which means we don't crack any or change any codes behind the people track. Okay. Okay, why they have those inputs and outputs? We need to know more details from the description in the inspector panel. Okay, this box is make the robot track people with the different mode. Okay, it's the same. This is changed to another word called people. It's not the face, which means how we define it as a people. Okay. Like what I told before, if you have arm, you have the torso, and you have the legs, and with the head on top the torso. So that's we can think of this structure is like it's like a people. Okay, we're gonna delete. We need to know more the inputs first of all, we need to know the parameter. It's very same. We just let people. We just want the pepper to move with the wheels and under it. Okay, it's not not important. Just some parameters to control how distance you want to move. Then we need to know the inputs. One is for on starts and another calls on stop. It's the same with the people the face tracker, and they have the actual one. They need to know the people ID. You can see there here. You can see there. They even have the event inputs, and there's a separate dynamic type of parameter, which means they need to know that the people ID just recognize it's the same people, the same person or not. So that's why we just need to add those two boxes here, because they must have a people ID to accept. And for the outputs, we know that have target lost and it was on stop and on target reach. It's the same one. It's the same one with the face tracker. Okay, back here I want to introduce another instruction box we call it subscribe events. Very important part. It's very important. The video instruction box. The first step, we need to search from the library. You just look if it exists in this library. If it exists, we just drag it and use it. If it didn't, we need to create one and try to use it. Okay, subscribe events. We just drop it here, compare with each other. It's the same. And then just give a quick look about the description. We know that this is subscribe signal on Now-T2 server are the events on the Now-T share memory when subscribed output speed will be triggered every time the signal is emit or the event is raised. From here, like the first class I also introduced about, they have in this choreograph on this panel. We know that they have this button right here. Every level on every level's the roots, we know that they always have this kind of a button. This meaning just you can add some events from an AL memory. You know, it's a long story. It's a long story because first of all, you need to know what is events, and another you need to know what is the AL memory. But those things is a combination for together. If you know more details, you can search from the website. But here I just give the simple way to explanation to explain it to you. The events just like if you want to trigger something, like you have low battery, that's the event. But the low battery, the driver gonna have trying to send a signal to try to tell you that the battery is lower, and then make Pepper see something, or even just try back find the home and trying to pause to charge by themselves. That's very important. It's those things from some drivers or even from the touch events. So like once you touch the sensors from the Pepper's head, you can trigger these events, but they all just stored in the AL memory. That's very important part. Okay, in here, for the subscribe events, and it's very equal to this add events from memory. Okay, if we know that standard box instruction box, we need to know the parameter. What is the events they just subscribe to? They just people detected. Okay, they use some events like people detected. From here, can we search about it? People detected. Okay, they also have those events like people detected. You can try to make this way. Add people detect and trigger this people tracker. It's the same way. Okay, it's nothing different. But for the box, we know that we have the chance. Okay, sorry. We have the chance to control the codes and to control edit some outputs. It's very customized by ourselves. That's unique difference between those events from between and this subscribe events. Okay, this is the subscribe the people detection, and for the inputs, we know they have to start this subscribe events, and then just wait for it, which means they just wait that people got it detected, and then got running for the next step. Okay, for the outputs, we know that have the on stop, and another one we call, sorry, it's on arrow. Oh, and if you want to make your project completely, maybe you can once you didn't detect the people or some internal error, you need to finish out the project or say something to tell people what's going on with Pepper now. Another one we call it on events, which means this, once they have the face detect, they have two signal outs. One is for stop this subscribe events. What do you mean? This is just a release the resource. Just stop subscribe, because we get the signal, and we need to unsubscribe to the events. And another one we call is trying to connect to another output ID. Here from the icon, we know that it's Python script. Because I'm familiar with those the icon. I know what instruction box I use. For the new users, I guess you can try to use any instruction box as Euro, and once you get use it to it, you can find the standard box from the library. Okay, if the standard Python script is they didn't have they only have the structure of the class Python of Python. They don't have actually codes inside. But in here, we know that we just changed some code. We added inputs and another for the outputs. And inputs is like input message, and it's a message, and another way people's ID. Okay, we double click on it. We can search from here. We define an input message, and it transfer P, which means three arrows is 3 arrows that to this one, and this is a pick one of that to the outputs. It's a people's ID. Okay, if you want to know details about what is the serial they stand for, and in each arrows in this 3 direction, what kind of the stat presented to, you just back to the website to search about it. But here we only pick the locations like from the one and the first row and the 0 column and another first I think this the Z axis the data belongs to this redirection. Okay, but it's not important. I just want to have some data and to know about it. Okay, and once it's got a people ID and it transfer the people track and it started this the people tracking. That's very enhancing. Okay, I just keep put simply why we I just tell you why we put those instruction box, because the people track have a request for the inputs. You must transfer to people ID. If it didn't give the ID, and there's some problem with that, or you can get the real data from it. Okay, that's the logic behind this projects. Compared with those in the first appearance, we know that it's the same way, but the inside of the face tracking and between the body tracking, we know that they just use just different instruction box, but it also depends on different in the parameter. All right, let's see the result. Okay. For the face tracking, we need the people just in front of pepper. But here for the people tracking, we just let people back to the pepper. They didn't get a face. So only need to people detection. Know the structures like from they really have the leg and arms even on the head. Okay, when the people just trying to move around, then pepper just follow, just detect the people and follow the people. Okay. Oh, okay. That's very important. Very different parts from between the face tracking and the people tracking. One of that is only depends on your face. Another one depends on structure body, which means people structures. All right, that's all about the face tracking and body tracking. Okay, thank you very much. I'm gonna try back to Jeffrey to continue our class.
Okay, thanks, Austin. Right, okay, so okay, back to my display. Right, so that is how we do the people tracking, and this particularly this application we introduced here for the movement development is because like we use it a lot in at home competition. So this example will be very useful for your preparation, especially for the competition. Okay, so yeah, something that you might want to try it out later on. Okay, then, oops, right. Okay, so for the next part, we will cover some basic movement. So basic movement over here is the body movement. So which means the whole body movement, which means Pepper will move around in a given with a given area. Okay, and we have a few ways to program these movements. Okay, there are a few ways. So there are a few instruction box that I will introduce here. So the first one is move along. Okay, so move along, it will make Pepper to walk according to the path planned in a specific .pmt file. Okay, so this move along is something I think very popular, especially when you want to design a longer movement. A longer movement means you want Pepper to have a very, how to say, not to say complicated, but maybe over the time of like 5 minutes, it's a long, and then Pepper have several movement. For example, like go front, then turn, then move in a circle, then go along left, and then so on. So which means it is it will follow a path, all right? It will follow a path that you can pre-design. Okay, you can pre-design the path, then Pepper will try to move along this path, and we will use another file called .pmt file to design this path, right? So this will be very useful, especially when you are designing, for example, like a dancing move, right? So in a dancing move, last week we learned about the body movement, so which means like how you can actually make the arms and the head and also the upper body to move according to certain dance move, for example. Then this .pmt file, it will help to how to say, to mesh with the upper body movement so that Pepper can actually move not on the same point, but it will move accordingly, right? So if you combine this with the body movement, then it will be complete like a dancing move. So which means like Pepper can move, like for example, around the stage, and then the upper body actually doing some action, and then with the music, then you can actually design the whole dance sequence, right? Dancing sequence. Okay, so this one later on we will show you how to actually create this .pmt file and create the path. So it is very similar like the timeline where you got an extra windows and extra things to actually do the design. Okay, so and the input output is very simple. So input is very normal, and output is either is success or failure. So if it runs successfully, then it's okay. But if got some error, then it will give you the failure, right? Then that is the .pmt file move along. Okay. Then next we have the move to. Okay, so this move to is very straightforward. Normally it's for one path, all right? So one path means like you want to go to a specific location. So from one starting position, you want to go to a straight line, go to another direction. Okay, but not necessarily a straight line because like it is actually move according to the given distance and angle. Okay, distance is x and y, and then angle is like how much you want the Pepper to turn when it moves, right? So x, y, z. So this one is very straightforward. You tell Pepper to go to point number x, y, and then turn what is the degree. Okay, so this one we have a very normal input, and then the output is on arrive at destination or on stop before arriving. So it's either we successfully finish the move to, or we have some problem, right? So that is the output. Then we have the move towards. Okay, so move towards. Okay, the name is very near to each other. Move along, move to, and move towards. But they are slightly different in usage. So move towards is move according to the given speed parameter, including x direction velocity, y direction velocity, and also the theta, until the three speed are set to 0 or the stop port of the input terminal is activated. Okay, else the robot will not stop. So please be careful when using this move towards, because like it is not specified the goal, the ending position where the robot will move, and it is finite, which means that eventually it will stop. But for this move towards, you are setting the speed, okay? Towards X direction, what is the speed? Towards Y direction, what is the speed? And spinning, like turning, what is the speed? And you need to couple this. So which means when you use this move towards, you need to always have something to stop the robot, okay? It's either you have another one that set the speed to become 0, because like when you set all 3 become 0, then it stop, okay? So that's one way to stop it. Another one is you use the stop bot, okay? To actually, you activate the stop, then it will stop. Okay, so later you will see how we use this. Right, then compass move to, right? So compass move to, you can see it is very similar name to move to. So that's why it is very similar to move to, but it actually add the function of vision correction, which make the movement more precise, but it take longer time, which mean the move to is how to say, is an open loop process. So which mean you just give the final goal, then Pepper will try to move to the final goal, but it don't really have any feedback. So which mean the movement may be not so accurate, because this X, Y, and data is, it can be not accurate if let's say like the moving condition is not good, okay? So it is using like some internal sensor to calculate, for example, the distance, but it might be very high accuracy. It might not be very high accuracy. So in order to make things more accurate, we can actually use, for example, the vision sensor to find the distance travel, for example. So you add additional feedback by other sensors to check the distance travel to see if we reach the point, right, that we want. So this is to how to say, use it for a more precise movement. For example, like you want a more precise movement that Pepper stop at a particular point, right? Or else if it don't actually stop, then it might collide into something, or it might not able to proceed to the next action. So this, you can use this compass move tool, but the drawback of this is like it will become slower. Okay, it will be slower than the move tool. Okay, right. Okay, so these are the 4 basic instruction box that we can ask Pepper to do some movement. So we already like put down an example. You can see move along, move to, compass move to, and then we have a delay and move towards. Okay, right. Then important thing is not just to drag the boxes, okay, but you also need to set the parameter, because over here the parameter is very important, because for example like move to, what is the XY data, that value is important, because like without that value, Pepper actually don't know where to move to, right? Okay, so we look at the first parameter, the move along. So move along, as I said just now, you need to create a .pmt file in order to specify the path, all right? So this is the Planar move editor, which is path.pmt. So in example, this one already given, but we need to create this file in order to use the move along, right? Sorry, yes, move along. Okay, so over here you can see we have a 2D, it's something like a map. So you need to specify the starting position, and then you need to start drawing the path. Okay, and then the path is like a combination of straight line, either horizontal or vertical, and then with some curve. Okay, you can use curve and straight line, and then you can set the parameter, for example, like what is the frame rate, what is the offset, and so on. Okay, so later I think like I will leave the detail of how to do this operation for Austin to explain. But over here, a few key important concept is like the green circle is the starting position, the red circle is the ending position. Okay, then in anything in between is the path, right? Then you need to set the proper time and also frame rate, because that will determine the speed. Okay, so over here you need to know like each grid is about 50 cm, so that is the distance. Okay, how you want to do this. Okay, right. So how to create this one? Later we will see how Austin actually explained this. Okay, so basically we have some procedure how to draw this. So you can see like we can actually design quite complicated sequence. For example, like you move to the left, then you make a half turning, then after that you go down, go straight, and then you turn and so on, right? Okay, then that is move along. This is for move along. Okay, then we have something. For example, okay, over here also we can see like on the top left hand side, we need to specify the .pmt file for the move along. Then we have the move towards, move to, and also compass move to, right? So move towards, you can see the x, y, and theta. That is actually the velocity, right? That's the velocity. Then for the move to and compass move to is the distant x and distant y, and also the theta. Theta is the in radian. One is in degree and one is in radian. Okay, so please be careful on this. Right. Okay, so these are the parameters that we will set in. So with here we give some example. You can key in this, but it's already in the example. Just to show you where to actually set the parameter. So you just need to open up the box, the setting, then you key in all this value. Then at the end, if you move the example, you will see something like this, right? Okay, so Pepper will move according to the path, and then yeah, it'll move. So you can see this, the movement is very gentle, and also it's turn and move, and also you can move diagonally. So you can see if let's say we design the upper part, then it become a very nice dance sequence, right? Yeah, and then like yeah, if you can imagine like Pepper, the upper body and also the hand and everything is with movement. Then you add a song, then yeah, we can actually like design the dancing movement. Okay, right. Okay, so this is the example. So I will pass back to Austin to show you the actual operation in choreograph. Okay.
Yeah.
Austin, pass to you.
Thank you very much. Okay. Pretty much all of the instruction box are pretty much easy because we just cover basic instruction from the animation and but not animation, from the movements. Like we talked before, all this we just pick some very important or just the usually instruction box we use when we compile our program. In this part, we just cover the four important, and sometimes it's a little confused when and how we use those different box between it. Okay, those two here. I just open this project. We know that we have the move along and move to and a compass move to and even move toward. That's from those important instruction box we use. But it's all from the navigation. We know navigation folder. We know that we have the compass movements, move along, move to, move toward. Even did have the walk towards and obstacle avoidance. But I wanted to introduce those for instruction box. And in the slides, we Jeffrey cover all the details about it. But I want to give you more and about how to compare with this box, and even not besides this box, other boxes. What step or the way we need to know a box in more details. Okay, the first of all, we know that this box have one function, and basically we just can drag into the compass moments. We need to quickly see the description like what I introduced before, and this have description like the instruction box can make the robot move to configured points relative to his current location using camera to correct deviation. Okay, just remember that they just make the robot move, and you need to configure some relative points, and then they just follow they use the wheel to move the points that you want to get to, and but they just added the actual one using the camera to correct deviation. Okay, and another one is called a move to, because from name we know that they just this only have the compass added before the move to. Okay, for the move to, and for see the direct description, we know that make the robot move to configure points relative to its current location. Okay, they didn't have to using camera to correct the deviation, so that's a totally difference between the move tool and the compass move tool. Okay. Okay. So in the first slide, we just grab the basic difference between the move tool and the compass move tool, and when and how we use it. And for when things, I guess so. If you want to move to somewhere, you just put some points, and then the pepper just move from the original points to another original points. But in the reality, the pepper have some the error rates. You know, we use the wheel under the pepper to move. Sometimes we just running on some floors and even on some ropes. Those floor is not it have a lot of obstacles and it's not stable. Sometimes the wheel can be slide little bit. In this point, I mean the pepper can't move from one point to another point correctly. They must have some error rates because they just it's very close to the destination, but they just not that very accurate. You can get their points. So that's why we have the compass move tool, because they use the camera to correct deviation. Once they detect the error rates or didn't get the points exactly, they can use the camera to correct the deviation. But everything they have the benefits, and they must have everything has the advantage or disadvantage. But you can use compass move tool to make correct points you want to make, but they need a long time to get the accurate points because they must detect with the camera, try to find it the right way. It's a very long time to detect about it. Okay, for another tool, we have the move toward and even for the move long. I just drag here, just delay those two, and we have the move long and move toward. Okay, move long. I guess you can know that this is a move long trajectory given by the tech.pmt. Okay, it just depends on the PMT file. Which means you can configure the path by using some tools or files. You compile and import into this project. Another one for the move toward, and they give more description about it, because I don't want to dive into more detail because they are very mathematical, because they just set x and a y and theta, even theta to configure these points. But in our mind, you just remember that we can configure the points. We can configure speeds and trying to give it the period time, move a little bit, and in those between those period of time, and they can move a long time. Okay, back to the projects. We know that they all use the they all use the standard introduction box. The first one we call the move long, another one we call the move to, and a compass move to, then move toward. And the logic is very easy because we started the projects. First of all, we try to move long, and if got a fail, and then just finish the project, and success, and trying to move to, and Excel to try to use the to render compass move to, and the last one for the move toward. Okay, I'm gonna try to give more details about each one, but it's a very simple way. You need to cover more. You should get the website to go details about it. Okay, for the move long, we know that it depends on the PMT file or other project or other configurations like those the standard box. We saw that they just have the black type, and it's a band type. We know that they didn't have any parameters. The only tell it's true, it's a failure or success. Okay, though there depends on the move long and the parameter of the move long. We just click this button. We know that we can find the Planar movement trajectory. They have the movements PMT file to depends on. Here I just pick up from the projects. When we click on the browser, we can search from our projects. We know that okay, in this project we don't even have the movements of PMT file, but they actually have the movements PMT file. Okay, back here we can create one or create a file from this from the Chronograph software. But here we have the we see the icon plus and we try to create the Planar movements. Okay, add one we call a movements. Okay, and this is a jump and pop it up with another panels. They just can give you define the real path the paper can run, but also they have properties you can to set. One important part is from the frame rates is they just is control speed how far and how often you want the paper to run. It's very simple and very similar with similar to the timeline editing. And also have the offset from the 0 frames and the take area and make every takes, then they have the five frame to move. Okay, and below that we have some trajectory orientation. They have the manual and automatically you can choose, because you can choose the direction for each points. But how? I'm gonna show you. First of all, I need to on the paper to move forward just like 2 frames. Okay, they just tell you how far that's is along. It's like 1 meter. Okay, and here we can change the direction about this points. Maybe we can try to turn a little bit to negative 90 degrees. 90. Okay, and negative 90, we can see that the arrow just turn into the left, which means when paper move here, they're gonna turn to this direction, and then we can add a new path here and running to this point. Maybe we'll just let paper to move here, but I'm gonna let the face to 90. Okay, trying to make that like this way. We just define the path as we want, because you can add a lot of new path. Why we have a circle here? Because paper if you want to turn around, you need to have the circle to follow with. you just can't to move like from the points. You don't from the points to directly the points. If you're gonna turn the paper, all right. Okay. Here I think it's it's very easy because you have the parameter to configuration. Even you can edit paths. You can edit more new path as you want. And if you have big pictures, you can add in more as you want. Okay, they have to actually running how run with the paper in. We're gonna click on it. We're gonna start from here and just follow the dots. The paper just follow the speed. And finally got here and trying to change the direction. Okay, then here we're just okay. Here we just find our moments PMT file, but in this instruction box we can find it from the projects and add it in, and okay with that. Then we run this move long. Also depends on the file with the moments.pmt. This is follow the trajectory as said. And then the move 2, we just we know that they really have special outputs. You can see here they have the dynamic outputs, a different type. It's not a black. For the first one, we know that if one move to somewhere, they're gonna tell you if they just arrived at the destination. Another one is called unstop it before arriving, because something gotta stop the paper, or some things just in front of the paper. This paper can't be avoided. So for some reason they just stop it, and you can try to finish other projects or even see something or other dating as you want. And the important part for move 2, we know that they just move one point to another point is very relative parameters to set. Here we just click on it. We know that they have 2 directions and another one for the theta, which means they have different grades. You can let the paper to turn different directions, or from 0 to 1 to 360 as like that. You can adjust it like as you want. There's have negative 180 to 180, and then they have the 2 directions. You can set this to the x directions like 2.5 and another for the 2.5s like that. Okay, that's because it depends on the distance. You can set the distance from the parameter. Another one we call some compass moves. It's very different between this one. We know that we use the camera to correct the direction, because they need to take a long time to correct the exact point you want to use. In some cases, for some applications, you must want a paper. You must have the paper in the real exactly points. If you want, you can use this compass move 2. But in the same, they have compare with the move 2, they really have the same parameter. And then the last one we call this move torque. Okay, before we move to the move torque instruction box, they really have the delay. Okay, why they have the delay of instruction box? We need to know the what's meaning of the move torque. Okay, here we know that they really have this standards output and on move failure. Yes, for some reason always the wheel got stuck or something. They have the occur some errors, or let you know that we didn't get that destination, and or didn't get the plan we set and before. Okay, another important part, so we need to know the parameter, and they are very differently, but they didn't have the distance to calculate. They only have this kind of a 0.2. This is a speed. They just call you 202 points meter 1 second in 1 second. and 0.2 speed meters in 1 second. But they also divide into different direction. And last one we call this theta. Theta. This is like to make paper turn around. Another important parts because period direction updates because in 1 second they just move like 2.2 2.2 at x direction and 0.02 meter in 1 second on the y direction. So after 0.1 seconds, they're gonna try to move another way, another again, which means they also always update to keep the paper running like this this configuration set in this parameter. Okay, so between those move Torah and move 2, we know that this one depends on the distance, and another one is very depends on speed we can control. Because if we don't stop the move Torahs, they always update the period of time. They always keep the paper moving. But in this example, sometimes we just have to delay 5 seconds, then stop the move Torah and let the paper stop. Okay, that's I think this is a very important instruction box for movements. We often use in our application, and also it's very important. Okay, let's just see the results. Okay, when we run this project, okay, this is the first we know that move along. We just saw paper just turn around and follow some trajectory. That's because they have the PMT file inside it. And they have to move from one point to another point. It's very relative. And they gotta turn around. Okay, this is a compass move 2. Because they will take a long time because they need the camera to correct the deviation. Okay, this is the last one, move tower, because they're always trying to move tower with that speed, and then after 5 seconds, then you're done with that. Okay, that's the results on how we use those four instruction box. If you got interesting about it, I bet you just after this class try it, because it didn't crack and modify any codes behind it. What you need to do just know the difference and how to use it. Okay, thank you very much. I'm gonna turn back to Jeffrey. Okay.
Right.
Thanks,
Austin. Okay, let me put back my screen. Okay, so now we actually have a good idea how to make paper able to move around and also can track, and also we can couple it with the upper body action, and also we can use sensor. So yeah, pretty much we can do a lot of, or we can program paper to do a lot of interaction tasks. Okay. With all the module that we have introduced. So as a practice or exercise for this movement, so you can combine the dialogue program to control the robot, to give the voice control, for example, to stop the following, because like when paper is moving, so it is easier that we use voice as the command, right? So it'll be easier, because like it's not easy like if you want to like give the command using the terminal and while the paper is moving. Okay, so this might be a better idea, that you can design some speech command to actually couple with your movement program. Okay, Then over here, you can try to practice, like for example, go forward, go backward, left and right by saying that to Pepper, and then Pepper will move accordingly, right? So this is one of I think is a very good exercise to combine the dialogue with the movement. And also you can use the please follow me or stop follow me or don't follow me to actually trigger the start and stop. Okay. Then when you say, okay, stop the program or exit the program or something similar, then the Pepper will stop. Okay, and there is a tips here that you can use. There is in the logic instruction box, you can find a switch case instruction box, which is you can put several case. Okay, over here is like, for example, the case for go forward, case for go turn left, turn right, and so on, or follow or stop follow and so on. Then you can put like, if I hear something with for this, then it belongs to case number 1, number 2, number 3, and number 4. Then whatever effect that you expect, you can make it become the effect of the case, the response for the case. Okay, so we can try this as the exercise. Okay, so you to right. So without further ado, because like we have quite a lot more content to cover today, so I'll proceed to the second part, which is the Pepper Multimedia. Okay, so Pepper Multimedia, we will learn how to use the tablet in front of Pepper. Okay, so the first one, which is I think the most commonly used, is to play video, right? Because by playing video on the tablet, you can actually give a very good explanation. For example, like when Pepper want to introduce some product, so you can play a video to describe the product and so on. So the interaction is actually much richer as compared to normal human being, because normal human being also, it can only use gesture and say, but you can't really show a video. Okay, so this one you can show a video on top of all the physical interaction, right? So this video, it can interrupt, pause, resume the video at any time, and then so there is a signal for the beginning and video. So which means you can fully control how you want to play the video. And you can see we actually have a lot of input over here. Beside on stop and on start, we actually have on pause video and on resume video. So you can actually pause the video, not to stop, but pause it. And also you can resume and so on. Okay, so this instruction box will be very useful. Then we have the show image. So other than playing a video, I think a lot of time you want to show an image. Okay, show an image, and this image can have a lot of function. For example, like you want to show a certain image with information, but it can also be decorative. For example, like you can show some, for example, uniform. Okay, you can show, for example, a bow tie. Then you can make like Pepper look like, for example, a bartender or a waiter, or and so on. So this show image, I think, is very useful in many cases. So you can display the picture on the tablet, and you can have control on either to hide it or to preload it, to start and to stop, and so on. So you have full control how you want to show the image. And I believe we already used this before, like in one of the example, to show and to hide. Okay. Then also we have the play sound. So couple with your image, couple with your, of course, your video, you already like play the sound. So sometimes you want to like show an image so that you can give like the uniform for Pepper. Then you can play the song while making Pepper dancing, right? So you can use this play sound, right? So you can play like MP3 format or WAV format or OGG format. And over here, there is a delay when playing MP3 and OGG format. So it's recommended to use the Windows with WAV file format. Okay. And later on, please also take notice that how to actually link to your media file, whether it's a video or image or sound file. Austin will show you like how you're supposed to put the file so that you can actually play it here. Okay. Right. So this is the example given, and then you can see like we just put all the instruction box that I've explained in series. Then we need to have some coordination when we do the show image. For example, over here, you can see there is a hide web page or display web page. Oh, you can even show a website as well. But it is actually look like an HTML file because like it is actually look like a website or to display a website for the tablet. Later you will see like how we actually use the HTML format to put or to manage all the media. Okay, right. Okay, so and this hide web page. Okay, later I think like Austin will explain to you what is this for. So to display, so this one is actually to show a website. So it will be also useful other than showing image, video, and so on. You can show a website, and this one, you can make it interactive. For example, like your website, you got certain button, you can design your button on the website, then a user can be interactive, right? So this one will give you the, for example, you can put a web address of certain temporary website that you want to display on the paper. So you can actually build website to be shown on the tablet so that to have the interaction with the user. And also you can use it like, for example, like for the user to input certain data for survey and other purposes as well. Okay, so with that, you can have effect something like this. So from here, you can see the tablet. Right. Oops. Okay, wait. I think I like press. Okay. Okay, yeah. So you can see this is how we can actually play a video on the screen. Okay, so this is the video. Right. Okay, right. Okay, so I will pass it to Austin to show you this demonstration.
All right. Thank you, Jeffrey.
Right.
Okay. I think this is the last part for the basic function of Pepper, because we just introduced the animation and speech. And here we have the last one we call it multimedia. And once you just open this folders, we can just divide into 4 different category. One of the for the internet, but I'm going to introduce in this project. In this project we didn't cover about that because I just leave the assignments after the class. Maybe you can use this instruction box to fetch the email and even send the email from the paper, because they also depends on some protocols, and once you just give the exact configuration, and they use the internet to send email, and because it's public. And another one we call the song. In the instance project, we just cover the play song, but still have the record song. You can record the song and send to other places, like some third party. You wanted to get the ASR, even get the NLP functions with the speech. You can record the song and we'll deal with that. And another one, we know that Pepper has the tablets. They really have, they can really show and display some pictures and video, audios. But here we can know that it's have to some, you can show them an image. Even I can show some app and web view. But here we cover the show image and the web view. And the last one, because the video parts, we know that we can play some videos on the tablets because it's very vivid. And if you show some video on the tablets, because the video have some strong words to see what's going on for your application. And also they have the record video. It's for maybe you have some functions like a video conference. You can record you have the way to record the video and send the video that to the remote. And that in that case, you can have this for materials with storage or video conference. All right, okay, but it's a last box here. But here in this project we could just cover most of that. In this project, it's a very simple. I just want to verify each of the box and how the functions you use in your application. And also those those instruction box, it's very similar. Maybe you can play the sound. Is compare with that even from the name and icon software setting, and the input outputs very similar. All right, in here, if you know that this all uses the standard box, what we need to do next, we need to know there's exactly the instruction want to tell us and what's function meaning. Okay, here I don't want to dive into the description for each one. You can get from the you can know this functions from an inspector or in the inspector with the description. But I want to mention that why they are different and how to configure it, because they just have different places to set the parameter. For the play video instruction box, we know that they have the parameter. It's like they only have one video, the video path. Okay, where we can find this video file, because this very standard is MP4 file. You just play the video. Okay, you must remember that in CoreGraph, you need to just must create folders like we call the HTML file. From here, if you don't have it, you need to can HTML. They already have it, but we can try another HTML one, and they just have folder created here. All right, but if you place video and songs, even show some image, you must have this folder. Just remember that it's very important. And in this folder, we just say they have the icon, this is the image, and have the songs files, MP3, and the video files with MP4. And though in this case, where we need in the play video, we just give the real name and with the suffix behind this name. So just a copy, because just copy this name and put it from here, then just they know where the video is from. Okay, for the inputs, we know that they have on start and on stop, even on the post. This is very easy. It's like a player, it's normal player to play the video. And they're gonna, once they finish out this this video, they just unstop it. And they even have some unstart events, just allow you to do some basic logic. When the music starts, you can do some movements to match this video. And for the next parts, we have the play sounds and important parts for the parameter. They really have the what is a copied name, but they have a browser button. We can try to find it and to pick it up. It's a very easy way to locate this place. And they have some more specific parameters you can set for the audios, for the balance L volumes, like that. It's very basic. It's like a sounds player and to play the MP3. And when this is finished out the songs, and they're trying to show image. So image that in this part they have a lot of inputs from here, but you should know it's very simple because it's also black color. They have must start this on start and on stop. They even have on hide image. They are on preload image, because they have different events let you to do the next thing based on those signals. All right. Oh, okay. And in the parameter parts, we can just type the name from here. It's very same, and then it's gonna find the image and display on the tablets. But why we have the delay 5 seconds, doesn't if you show the image on the display, and they always gonna show it. When you need to have some signals like or events like trigger that if just hide the image, don't want to show it. That's that's the example how we use it. You don't need to use delay. You can use some other events or even other boxes to try to hide this image. There's also basic on the basic logic. Once it's gonna stop it, it's gonna try to hide the web. Okay, they had to hide the web page and even had this display web page. Oh, this is those two boxes are combined together. Okay, and this also combination box. Well, we can enter each one. Here we can hide web view. Okay, first of all, we should know why we use the hide web view, because according to the description, the hide web view is the content on tablets behind the generic cover. Which means we need to hide the web view service before we just open the web view, because they need to hide everything and to release all the resources from tablets. Then I can try to open another browser to show our website. So that's the basic logic behind it. Once you're gonna show some web page, you must have to hide the web page and gonna display again. Here they only use the show web view. It's a very easy one. They need to accept the address, the website address, and to show it, because they have the web view web URL to accept it. Another one we're gonna start this to show web view. It's very easy, and here we'll just use the edit box just to transfer the screen into the show web view. Okay, that's a very important part. It's a very important notice. Notice we need to do with the show web view. All right, just back to the whole project logic. We know that we just play the video, I play sound and show image and hide web page and display web page. But in here, because we don't have the real robots, we just show because it's very easy. We just saw the video from Jeffrey, because they just play song, play MP4 and songs and play the video and then show image and the show page. But here, I just 10秒钟之后，我们是一个隐藏。Okay, I don't have a complete videos for showing how the whole project, because there's some mistakes by the video editing, something. Here we just saw the images showing. Before that, they really have the kind of video playing and the audio playing, and it shows the image, then hide in 5 seconds. In 5 seconds, it hides the image, then show the web page. But here we don't actually see the web page because they have some network problem. But I'm not sure about it. It's also about the video editing. But those boxes basic. You can really use it in paper, and they're gonna work and in the real robot. Okay, and that's basic parts about the multimedia, and about the other parts, fetch email. You if you want to use it, just drag into according to the description from the inspector. You know how to use it and put it into your business logic. Okay, here I'm done with that. Thank you all, and I'm turn back to Jeffrey. Thank you very much.
Okay, right. Thanks, Austin. So let me put back to my screen. Okay, so we have done for the multimedia, and there are actually many things that you can explore. As Austin say, there are many more other things. You can just drag out the standard instruction box, for example, like the send email and things like that, and you try to like play with the configuration, and it should work. Like if let's say your network and everything is properly set up. Okay, right. So we have come to the conclusion. So as the time we have about like 15 minutes more before the end of the session. So let me conclude that what we have done. So we have done 5 classes for Pepper development. Actually, it's not very long because like we only have 5 sessions and each session is about 2 hours. So we cover from the very basic, like how to install, how to set up, and then we learn the first very important function on the second week, which is the speech interaction. So in the speech interaction, we can make Pepper to say something, and also can make Pepper to hear something, and also we can design how Pepper can respond to certain questions and try to hold a conversation. You can actually design the conversation to be very like deep and with some context and so on. So if you write a lot of the Q&A database, Pepper can actually hold quite a long conversation with your user. So it is very enough for example, like you want to use Pepper for example, like interact with your user in a library, in a retail shop, in an office, in many cases, right? So you can use just the speech interaction. And also from the speech interaction, we know that we can add some action, for example, like the animated say and so on, right? Okay, then on the third week, we learn about the visual perception, which is how to use the camera at the head to actually do, for example, like face recognition, face detection, and so on. So this is very important because like we mainly use Pepper to interact with human. Okay, so that is the most important part, that we try to always use Pepper to interact with human. So detecting the face, detecting the human is very important, and by using that, you can do a lot of things, right? For example, like once you detect someone, then you can approach and try to start a conversation. And when you start the conversation, then you can provide some services, you can provide some information, and so on. So that basically is what you want to develop Pepper for, right? Okay, so okay, with that, you already have a lot of fundamental function that you can design a lot of Pepper for various applications. Then last week, we learned about the body motion. So how to make we learned the timeline, and also we learn how to like directly move the arm and the head of Pepper to actually design certain action, certain posture, right? Then we can play it in the loop, and you can get the body very nice body motion, because like the design of the Pepper robot itself is very human-like, and also the 20 plus degree of freedom, the joints, will actually create very nice posture, which is very mimic to human posture. And that is an advantage that we can make Pepper very lively, because like with the body motion, you can couple, as you remember in the timeline, we can have several layers, and you can add like speech and other things together with the body motion, and then you can have very nice motion with behavior. Then today we add in the movement, right? The movement. So not only Pepper can do some action, Pepper can say something with the behavior and so on, then you can also make Pepper to move around in a given environment. So it is not just how to say, always stand at the same position and try to do things, but it can also go and approach, for example, like step forward to find the user, or to actually track the user. For example, one very interesting application that we talk about is, for example, like in a museum, you can use Pepper as a guide, for example. So Pepper can move, like you have a museum, for example, so you know exactly like all the things that display, and then the location and so on. So you can actually plan the path by using the tools that we just mentioned just now, the PMT. So you plan the path, and then you plan the movement, and also you plan the content. So the user can actually follow the Pepper, and then you can introduce the display item one by one. And yeah, this whole thing is actually very much like a tour guide, right? Okay, then not only like Pepper can explain things like human, for example, like say the content and also do some body gesture, but it can also enhance by showing the for example, like video and play sound, play song and so on. So not only like dancing, but also like in a lot of cases, we can have multimedia And also, for example, like just now, we can see even you can open up a website, and you can actually design the website so that you can have some input from the user. For example, like it become a GUI so that it can interact with the user to get some particulars. For example, like the user maybe can do some registration or some survey for some inquiry, and you can send some email and so on. So there are actually many things that we can do to put all these things together. Okay, so after this, let's have a look on some practical application. Okay, all right. So for further development, for example, like using choreograph, we can actually add in for speech interaction, we can add in more multilingual dialogue, for example. Then we can also use online speech recognition API. For example, like we know we can use the Python box, so we can integrate with a lot like iFlyTech, Google Speech, and so on. Right. Then also automatic reply. So if you feel like the question and answer way of Pepper is a bit not enough, of course you can use third party, but important thing is to design the dialogue engine so that Pepper can actually become an online chatbot, for example, and so on. Then for visual perception, yeah, a lot more. You can actually use, for example, like the online API for face recognition, for object learning, object recognition, for example. There are a lot way. You can also use third party, like Python based, for example, YOLO 5 is using Python based. So you can run parallelly with the choreograph to enhance the visual perception of the Pepper. And the multimedia, of course, like develop interactive interface HTML. For example, over here, you can see, I can play this. So there's some field that the user can, for example, like, I don't know where's, I hope I can find, yes. So there's actually two buttons here that the user can actually press so that you can have some interactive interface, right? Then you can go further with Naochi SDK. For example, like over here, for the visual perception, we can do a lot more things. So you can, from Pepper, we can get the picture. Then after that, you can use third-party software to do, for example, deep learning based of object recognition, posture detection, for example, like OpenPose, YOLO that I said just now. And also you can add in, for example, like QR code, barcode scanning, April tag or AR tag, and so on to get more information from the surrounding. Then the movement, you can, yeah, even do until like a full-scale slam and also object avoidance. Slam means like you can build a map and then let Pepper to move, do the path planning from point A to point B, and so on. Then, of course, like others, for example, like access database, IoT control and stuff. For example, like over here, I can show you one example that we use OpenCV and also make Pepper able to detect the waving. Yeah, so this is the thing. So the waving gesture. Right. So let me go a bit front. Okay. Yes. So for example, over here, so I try to detect the person waving. Right. Then with the waving, then Pepper can actually find that person. Right. And then it will start to hold some conversation. And this one is actually the localization, which means this one is actually the navigation. So Pepper actually can do the path planning to move from one point to another point, and then to find some objects and so on. Right. So this is some application that we can do with the Naochi SDK. Right. Right. Then we can actually make further. For example, like we have one example that we can make Pepper as a retail stuff. For example, like in a convenience store, we can use Pepper to become a store staff, for example. Then it can interact with the Pepper. Over here, for example, like we do the face recognition to detect the person. Then we know the person, we can find the record and we can do some recommendation. Sorry.
Yes, please show me the way.
Okay, then it can also, because Pepper can move around, so it is not just an information kiosk, but it can actually lead. It can bring, like just now I said, the tour guide, it can lead the person to oops, sorry. Okay, wait. I'm not good. Okay. right? It can lead the user to the place where the product is displayed, right? Things like that. Then you can also scan QR code to get the information, and actually you can even like do payment, right? So if let's say you link this with the store payment system and so on, yeah, database, and yeah, a lot more things that we can do, right? So as an exercise, try to combine all the functions that we learn, try to develop, and we can actually do several service robot application. For example, instructor of science museum, reception for office, bank, and so on, and also shopping guide and so on, right? So these are all the exercise, and if you can do this, you can actually like link to the competition. Okay, so give me a few more minutes time so that I can introduce you some of the competition development. So we will have a scenario. This is the at-home scenario where we have a typical home environment. So you can see like on the left-hand side, this is the typical home environment. We got the living room, bedroom, and so on. But for at home, we don't have a specific design for the home. So we will have something very similar like a home environment. Okay, then the robot's supposed to be interact with some commonly used household item, for example, mineral water, can bottle, some snacks, potato chips, milk bottle, milk carton, and some sweets and so on. So these are all the typical objects, household objects that it will be involved in the task. Then for at home, this time for this 2022, we already published the rules, so you can go to the website and read the rules for at-home education. And at-home education rules is actually paired with the at-home rules. So this year, the 2022 rules for at-home is actually paired with 2019 rules for the at-home. Okay, so you need to read both. Okay, if you want to know the detail, you read the at-home rules, and then the at-home education rules is actually the adaptation from the at-home rules. Okay, and this year we have 3 tasks that we will use it as the at-home education challenge task. Task number 1 is to carry my luggage. Task number 2 is find my maid, and task number 3 is receptionist. So we will use this as our competition task. So if you want to know more about this, please go to the website and read the competition rules. Okay, then also we have this open challenge. Open challenge is for the final, and also open challenge is used for our online challenge as well. So just to give you the info, just to remind you that for this time in Bangkok, so we have the on-site challenge and also the online challenge. Okay, we have both tracks, so it depends on which one you want to join. You can choose. So for the online one, it is very similar to 2020 and also 2021. So you can refer to our YouTube channel or Bilibili channel to find more information from there. Later, I will show you the link. Okay. So now I just want to show you some team video. So this is the team video. So Camera Rider is my team. So previously we've done, and this is the actual video taken for RCAP Tianjin. Okay, so RCAP Tianjin, and then you can see how we actually develop Pepper for the at-home task. So this one is the speech and person recognition task. So Pepper can use the camera and then to detect how many person, and then it will tell like how many is male and female. So if you still remember, we have the gender recognition and so on. Then this is the interaction one. So Pepper will try to answer the question and also try to face the person that asked the question. Right, so you can see Pepper is actually moving towards the person that asked the question and try to answer the question.
Located? Where is the hotel de Glace located?
Okay, so this is how it tried to answer the question.
And my answer
First computer bug
is the first computer bug, and my answer
is Mark Zuckerberg.
Okay, right, so this is the speech and person recognition task. Then we have the second task, which is the cocktail party. Right, so this is for the previous one. So we try to go into the room, so it will navigate into the room, and then it will try to find the person, and will try to approach the person. Okay, then it will try to talk to the person. Okay. Okay, so interact with the person. Okay, I will fast forward the video to cut short the time. Okay, then we have the Find My Mates, for example. I'll show you Find My Mates after this. Okay, I'll show you Find My Mates after this. Okay, this one I'll show you later. Then we have the restaurant task. So restaurant task is basically using the, like just now I said, the waving hand. Okay, so I think this one you saw, like it will try to see the, yeah, it will detect the waving, and then we'll try to move. Yeah, so this is a restaurant task. Okay. Then we also have, for example, like this one. Okay, my web a bit slow to buffering. So this one is one of the research in my team that it used the Oculus to actually make Pepper as a telepresent robot. Okay, right. Okay, so let me show you. Yeah, this is a Find My Mate. This is one of the tasks that is going to be the competition task this year. So Pepper will enter the room, into the living room, and then it will try to interact with the person, right? So for example, like you come to this person, right? Then it will tell the features of the person that interact with Pepper just now, right? If you remember. So for example, like over here, you can see the information. So yeah, so it can know like this person is a female, then roughly the age, and then the name. You can get the name from the conversation, and also like other features. So this is Find My Mate. So it's like you ask Pepper to go to the room, try to talk to someone, and try to understand the features. Then you come back and report the features. Okay. Right. Then we have another team which is also is very good. So they send this team video for in 2020. So we can see some other development. Okay.
Hello, I am Pepper.
So for example, like they do the Pepper simulation, and also this one is for the object detection. So using the Pepper camera, you get the image and try to do the object recognition. Distance and localization to find the distance by using the sensor. Right. So this one is using the way how to learn the movement. Right. And human robot.
What is your name?
John.
John. What is your favorite drink?
Coke.
Coke. I will ask Coke to the bar.
Okay, so this is basically the team video. Right. So one more is like another team that we can develop for our online or on-site challenge, open challenge, is you can design some application that relate to or address the current pandemic situation. So there are actually a lot of things that, for example, you can get a guide in the hospital, for example, the telepresent for some real event and so on. So yeah, there are many things that you can do with Pepper. Okay, so this is the link. So later on, you can access the link from our robotforall.net. You can find this link, the materials, and you can find this link. So this will point you to our YouTube channel or video channel that all our previous technical video challenge, all the submission onto 2020 and also 2021. And also we have the live video for the final. So you can see if you're joining the online challenge, you can find how the final is being done in the previous years, and that will be the best reference for you to prepare for this year online challenge. Okay, so the timing is just right, 9:30, 9:35. Okay, so we have actually covered everything for the online classroom, and this is the last class. So I will open for some Q&A time, but let me finish all this thing first. Okay. So there are a few announcements that I would like to make. One is like if you are interested to join the competition, you need to know, you need to do some preparation. Okay, so let me show you the website. Okay, I need to show you the website. I need to, okay, let me show you the website over here. So I'll show you. So if you go to our online challenge, if you enter here, okay, so you scroll down. So the next thing that you need to do if you want to join is you need to submit this is what we call the technical review and challenge. All right. So for at-home education challenge, we have two. Just now I said is either you want to join the on-site challenge, will be happen in Bangkok, July, or you can join the online challenge, which is you can join, yeah, and it also happened during the similar time, okay? So no matter you want to join online or on site, you also need to submit this technical review and challenge. So each of the team, you need to prepare the materials. So 3 materials is required for you to join, for you to submit. So one is the technical video, another one is the technical paper to explain your video, and then the third one is the website. The website is if let's say you have some educational effort. If no, then it is optional. You don't need to submit for the team video. It's fine. So the submission site will be out soon. Okay, you can find the link later on over here. Okay. But what you need to do is you need to submit this video and paper. You don't need to be worried so much. Okay, you can find a lot of reference. So I have example that you can find over here how a video look like, how a paper look like. So you need to submit by the deadline is May 27. Okay, so this is the deadline at the end of this month. So you submit these materials, then we will do the review, and you are selected. Then you can join for the either the on-site challenge or the online challenge. Okay, so the difference is like, yeah, one is online and one is on site. And also if you can come to Thailand, I will encourage you definitely to join the on-site challenge, because you also able to join the on-site workshop, which is we will have real pepper over there for you to experience the development and so on. So if you're interested to develop pepper, although you don't have a robot, okay, you can sign up for the on-site challenge and you will have the chance to use Pepper for the development, and also you can use the same robot for the competition as well. So this is for the on-site team. Then for the online team, yes, definitely, if you can't actually travel to Bangkok, you can still join our Pepper challenge with our online challenge. Okay, so the online challenge will be very similar to the one in 2020 and 2021. So you can go to our YouTube channel. Just now I show you the link to see how it is look like, right? So whichever challenge that you want to enter, you also need to submit this team submission materials, okay? Which is, it will due on May 27. Okay. So I look forward to receive your entry, and I really hope to see you in either Bangkok on site, or I will see you online as well. Okay, so with that, I have covered all the updates for the competition at this point, but later on we will have additional announcement. Then we will send you through the email and so on. Okay, so now I would like to open up if you have any question you want to ask about the Pepper online classroom, and also you have anything you want to ask about the competition. Okay, and we have Austin over here. So if you have any question, technical, or you need some support from SoftBank, yes, we can also discuss from here. So I would like to know, like, if you have anything you want to ask, and I can see in the list like we have some from Thai. So if you want to ask in using Thai, yes, it's fine. Also, our LOC is also over here. So I would like to know, like, the audience today, if you're interested to join, do you have any question you want to ask? Is there anything? Or can I invite the LOC to actually make a brief summary of what I've just said for the summary of the class and also the summary for the competition preparation? Is that okay?
Okay.
Okay.
Hi Jeffrey โอเคครับสวัสดีครับก็สำหรับในคลาสนี้เนาะก็คือเป็นการที่เขาเนี่ยพูดถึงในส่วนที่ใช้เปเปอร์นะครับในการขยับไปข้างหน้าซ้ายขวาหรือว่าเป็นการเดินตามคนนะครับแล้วก็เป็นในส่วนของการใช้แท็บเล็ตด้านหน้าเนาะที่เป็นสำหรับการโชว์มัลติมีเดียนะครับไม่ว่าจะเป็นการโชว์วิดีโอโชว์ภาพหรือว่าแม้แต่โชว์หน้าเว็บไซต์นะครับซึ่งการที่เราทำให้มันสามารถโชว์หน้าเว็บไซต์ได้เนี่ยก็ทำให้เราเนี่ยสามารถที่จะ develop อะไรที่สวยงามหรือว่าปุ่มอะไรที่มันพอเข้าใจง่ายแล้วก็สร้างได้ง่ายขึ้นนะครับก็มีวิธีการนำเสนอมัลติมีเดียแบบนี้เช่นกันนะครับโดย assignment ที่เขาให้นะครับก็คือให้พยายามที่จะรวมนะครับในส่วนของฟังก์ชันที่เราเรียนมาทั้งหมดเนี่ยไม่ว่าจะเป็นในคลาสแรกเนาะไม่ว่าจะเป็นในส่วนของที่เป็นimage ตัว visual perception นะครับตัว movement แล้วก็ในส่วนอื่นที่เป็น speech หรือว่าในส่วนที่เป็นmultimedia ที่เรียนมาวันนี้นะครับก็เขาให้พยายาม combine หรือว่ารวมกันทั้งหมดเนี่ยเพื่อให้ไปทดลองทำอะไรสักอย่างหนึ่งโดยที่เขาเสนอหัวข้อขึ้นมาประมาณ3หัวข้อนะครับก็คือหัวข้อแรกก็คือเป็น instructor ก็คือเป็นคนที่แนะนำนะครับในส่วนของพิพิธภัณฑ์ในที่เป็นวิทยาศาสตร์และเทคโนโลยีนะครับหรือว่าในส่วนของที่เป็นมิวเซียมที่เป็นในส่วนของมิวเซียมอื่นๆนะครับอันที่2ก็คือเป็น reception ก็คือเป็นพนักงานต้อนรับนะครับสำหรับHall of Government หรือว่าในแบงค์นะครับอันสุดท้ายนะครับก็คือในส่วนของ shopping guide ใน shopping mall ก็คือแบบเป็นผู้ช่วยเป็น personal shopper ครับก็คือช่วยแบบแนะนำว่าสินค้าอันนี้เป็นอย่างนี้อะไรประมาณนี้นะครับก็อันนี้เป็น assignment ที่เขาเสนอมาให้ทดลองทำดูนะครับแล้วก็ในส่วนของ task at home ปีนี้นะครับก็สามารถที่จะไป follow ได้นะครับที่RoboCup @homeedu.org/rules นะครับหรือว่าในสไลด์หน้า34เนาะเขาก็จะใส่ลิงก์ไว้ให้นะครับโดยที่ task ของปีนี้เนี่ยจะเป็น3 task นะครับก็คือเป็นcarry my luggage เป็น find my mates แล้วก็เป็น receptionist เนาะโดยที่final ก็เป็น open challenge นะครับโดยที่สามารถที่จะอ่านตามกฎที่เขาให้ไว้เลยเนาะโดยที่มันอิงจากตัว rule books ปี 2019 นะครับแล้วก็เขามีคลิปวิดีโอตัวอย่างเนาะว่าแต่ละทีมเนี่ยเขาโชว์อะไรบ้างอะไรประมาณไหนนะครับก็สามารถที่จะเข้าไป follow ดูได้นะครับส่วนสุดท้ายนะครับเป็นในส่วนของการสมัครหรือ registration เนาะก็คือเขาก็จะมีหน้าเว็บเนี่ยครับที่เขาเปิดอยู่เนาะเป็นRoboCup @homeedu.org/challenge/RoboCup 2022 Bangkok นะครับโดยที่สิ่งที่เขาจะให้ส่งหรือว่า submit ไปเนี่ยก็คือมีในส่วนของ technical video นะครับก็คือโชว์ว่าหุ่นยนต์เราเนี่ยทำอะไรได้บ้างเนาะโดยที่เราสามารถจะถ่ายกี่เทคก็ได้เนาะเอาเป็นbest performance นะครับแล้วก็ในส่วนของ technical paper นะครับก็คือเขียนเป็น technical report นะครับแล้วก็มีการใส่รูปใส่อะไรเข้าไปเนี่ยเพื่อที่จะอธิบายว่าไอ้ระบบที่มันทำงานในวิดีโอเมื่อกี้ครับก็คือทำงานยังไงแล้วเราสร้างอะไรขึ้นมาเรามีการพัฒนาอะไรยังไงบ้างเนี่ยก็สามารถที่จะอธิบายเพิ่มเติมลงไปนะครับใน technical paper ได้นะครับแล้วก็ใน material สุดท้ายเนี่ยแต่อันนี้เป็น optional material เนาะก็คือในส่วนของทีมเว็บไซต์นะครับโดยที่ทีมเว็บไซต์เนี่ยสำหรับการให้รางวัลที่เป็นในส่วนของBest Education Award นะครับโดยที่อันนี้เนี่ยเช่นว่าสมมุติว่าเรามีการเรียนรู้นะครับในส่วนของเปเปอร์ในวันนี้เนาะหรือว่าเรียนรอสเรียนอะไรอย่างเงี้ยครับแล้วก็ทำการอัดวิดีโอนะครับไปลงในchannel YouTube ต่างๆหรือว่าในเว็บไซต์ของทีมนะครับก็สามารถที่จะsubmit ตัวนี้เนี่ยขึ้นมานะครับเพื่อที่จะไปชิงรางวัลนะครับในส่วนของ Best Education Award ได้นะครับแล้วก็เรื่องการ submit เนี่ยมี1อย่างนะครับก็คือวันสุดท้ายที่จะ submit นะครับคือวันที่27นะครับเดือนพฤษภาคม 2022 เนาะโดยที่หากท่านใดมีคำถามอะไรเนี่ยก็สามารถที่จะอีเมลนะครับไปหาเขาได้เนาะอีเมลก็จะอยู่ในสไลด์นะครับบรรทัดล่างสุดที่เป็น contact us เนาะที่เป็น oc@robocup@homeedu.org นะครับแล้วก็หากท่านใดมีคำถามนะครับก็สามารถที่จะถามขึ้นมาได้เลยนะครับไม่ว่าจะเป็นภาษาไทยหรือภาษาอังกฤษนะครับokay Jeffrey
Yeah, I have a question. Yes.
พี่ครับถ้าจะเข้าร่วมแบบทีมจูเนียร์นี้ทำแบบเดียวกันเลยไหมครับ
เข้าร่วมลีกนี้ใช่ไหมครับ
ใช่ครับ
Jeffrey he want to ask that if he want to join the social standard platform league but in the junior team the process is same as the major team and that shown on the screen.
Okay, so for us, okay, this time we have the standard platform and open platform. So this one is the at-home education challenge. Okay, so it is different from at-home challenge. At-home challenge is totally a different league, right? So we are talking about the at-home education challenge, and within the at-home education challenge, we have standard platform and open platform. And today we are talking about the standard platform. So if you want to join the Pepper Challenge in at-home education, yes, welcome to join. And that is what we are talking about here, right? So you need to submit your team submission materials by May 27 in order for us to do the revision. And if let's say you pass the revision, then you will get the qualification to join our workshop, on-site workshop, and also our on-site challenge in Bangkok in July. Yeah.
If he is the if there is the junior team
Yes,
the process
the
is the same. Yes, okay.
Yes, junior
Thank you.
and senior, we actually have the same, because like in at-home education, everyone is actually beginner. So everyone start from fresh. So everyone will follow the same, and our procedure will be the same. All right, will be the same. So you just need to prepare the materials and submit to us by before 27 May. Then we will do the selection.
ครับก็เหมือนกันครับแล้วก็เขาสอบถามเพิ่มเติมได้ไหมครับว่าจะเป็นแข่งออนไลน์หรือออนไซต์ครับ
น่าจะออนไซต์
โอเคhe joined the on-site challenge.
Yes, so the on-site one, you can come 1 week earlier and you can join our workshop. And if you don't have Pepper, you can join the workshop to learn about the Pepper, the hands-on, and you can use that Pepper to join the competition.
Okay, thank you.
Okay, so but no matter you join online or on-site, you have to submit the material first by 27th of May, because that is the way we can select you as the qualified team, and only qualified team can join, whether the on-site or online, right? So if you are not qualified, you cannot join any of the challenge actually. All right, so make sure you submit the materials, you prepare the material and submit the material before 27th of May. Okay. All right, is there any more? Okay, so is there any more question? If no question, all right, thanks a lot. And we really like, yeah, over the time for a little bit. So thanks a lot everyone joining this session, and I really grateful that you still stay with us until like the 5th week. So I really hope to see you in Bangkok or in the online challenge, okay, in July. And also I would like to say thanks to SoftBank Robotics, Austin, and also the rest of the engineers to support this this online classroom series, and also to show the demos and also the explanation on the choreograph. And I look forward your support, continued support in Bangkok as well, right? Okay, so with that, and also not forgetting the LOC from Thai, that you support us in terms of like language support, right? And I really like appreciate the LOC and also the Thai community that joined this class actively, and also I look forward to see you in Bangkok soon. Okay, so with that, I thanks everyone, and I wish you good luck. So hope we can keep in touch. You can send email to us, or you can discuss things with us in the class group and so on. So I hope to see you around, and I look forward your entry application, the team submission by May 27th, and I hope eventually we will go to the RoboCup together in Bangkok in this July. Okay, so with that, thanks a lot, and we would like to close this session. Okay, so we have done everything successfully. So hope to see you soon. Okay, see you. Bye bye.
Goodbye. Bye, Jeffrey.
Thank you, Jeffrey. Bye bye.
Thank you. Bye bye.